Today we're going to be doing a restoration on a Sony Walkman WM-F10 portable cassette player. This one's pretty special. The owner found it in basically open box condition from an elderly person who had bought it on a trip to Japan when they were new. And they basically didn't ever use them. So that was the original box you saw. These are all the original pamphlets, the original bag that it came in, everything. This is the first video I've done in a while. I realized that I don't upload very often. I really would like to upload more often, but it's really hard to find the time to record these things. I do repairs. I've been doing repairs constantly ever since the last video, but I don't ever have the time to record them, edit them, voice over them, and upload them. It's hard. I do this as a hobby, but I also do it as a source of income, and so it's like my priority is usually getting stuff done, not recording videos. But this is such a cool little cassette player. I wanted to record a video of the process. This is a little sleeve that you can put over it. It's like a belt clip sleeve, and that's the original strap that I was holding there a while ago. It's never been unpackaged and unwrapped. It's all brand new. So this is what it is. It's very compact. It's almost the same size as a cassette case. And that's the trick with these is they actually slide out. The whole side with the head slides down to give it room to actually fit a cassette inside. So the size is kind of a trick, but it's a really cool little mechanism how it slides out like that. And with cassette players this old, the belts inside are always completely disintegrated. Sometimes they've even changed from rubber into like this gooey tar that's like it has to be cleaned really well before you can replace the belts. So that's what we're going to be doing with this one today. So first we're going to open it up. You take these two screws off to detach the door. These attach it to a sliding piece inside. So we'll take those screws out. And then once you've taken them out, you can pull the door off, but don't pull hard because it's still connected. This is a model with a built-in radio, so it has a ribbon cable going to the door, so you can't take the door completely off. But we needed to take off that piece so that it would expose these two screws on the bottom. The one of them I'm taking out right now, and there's the other one. And then there's two more below them that we're going to take out next. Once you get those screws out, you can remove the bottom of the shell. And again, it's kind of a delicate process. Oh, one more thing. We got to remove this volume knob. And it's held in by a big screw in the center with two holes in it. And the easiest way to undo the screw is to actually stick a pair of tweezers in the holes and turn it until it's loose enough that you can thumb it out the rest of the way. I'm sure Sony probably sold some stupid technician tool for this back in the day that was a key for unscrewing these, but you can just use tweezers. And then once you take that off, you can pull the volume knob off, and then be careful because there's a little plastic ring that goes below it, a little washer, and you don't want to lose that, or otherwise the volume knob will be scratching against the metal of the case. Once you've removed that, then you can remove this bottom shell, which, like I said, is kind of a delicate process. You want to go slow, make sure you're not breaking anything while you go. You kind of want to get it loose from the hinge side, and then once you kind of open it like a book a little bit, you can pull it out towards you to get the buttons freed from the bottom side. And this little piece came out. I've never had that happen before on these, but it's basically like a little color insert for the play button, and I guess they're taped or glued in at the factory, and the glue is probably failing on this, but I didn't re-glue it on this because they're held in on their own when the rest of the chassis is reinstalled into that shell, so I just left it as is. Gonna zoom in a little. So those brass wheels are, they normally have a belt wrapped around them, but when the belt gets old, it disintegrates and breaks apart and sticks to the brass, and it actually starts corroding the brass. And the stuff is really nasty. You really have to clean all of it out, because if you don't clean it really well and you put a new belt in, it's just going to get the new belt all oily and gooey too. And it's going to sound like shit. There's no point in trying to do a belt replacement on one of these if you're not going to take the time to properly clean them. I also want to apologize in advance for the horrifically shit camera angles that you're going to get throughout this video. This is my first time trying out a new camera rig that I bought. It's kind of like this necklace with a mount for my phone, and it really seemed like a good idea when I bought it, but man, the angles are just I basically had to watch the phone instead of watching what I was doing to make sure that I had good angles, and it's impossible to be doing that the whole time when you're working on something so delicate. So forgive my terrible angles. Anyway, what I'm doing here is I'm using a wooden toothpick, which is kind of, I don't know if you'll find this advice already online or not, but I kind of figured it out on my own that it's just a really good tool for getting this goop out, because the wood is not going to scratch or like otherwise damage the brass, because the wood is soft. It's soft enough that you can really like forcefully shove it into the crevice of the brass wheel without damaging the brass, and it's soft. The softness will help it actually flatten into the very tiny thin grooves of these brass wheels to help clear out the corrosion and gunk. So I just keep changing out toothpicks every time they get too gummed up, and we just keep going and rinsing and repeating until all the goop and gunk was gone. And then once I've done as much as I can do with the toothpicks, I'll move on to like using Q-tips or whatever. But right now I'm just focused on getting the existing like big pieces of belt out. This one is like in the early stages of turning into goop, where some of the belt was actually still like able to be pulled on without it like turning into goo. But this middle brass wheel has like gooped rubber, so I tried touching it and it just got on my fingers. So we're gonna go back to using the toothpick here, and I'm just trying to get all the rubber that's like easy to get touched here. I'm trying to get that off so that I don't accidentally make a mess while I'm working on this by getting my fingers continuously dirty and then spreading the goop everywhere. It's really nasty stuff. You really have to like be careful not to get on your clothes or on anything that's fabric, because it will stain. It will never come out, and then it like stays on your skin too. Sometimes you can get most of it off by rubbing your skin with isopropyl alcohol, but obviously that dries out your skin. It's not good for your skin. Anyway, so after I've kind of cleaned up the general mess as best as I can, it's time to lift up the PCB so that we can really get a better angle on these brass wheels, and also get to the motor. So there's 2 screws here to remove. One of them, I already did it. It's in the middle of that copper color ribbon cable, and then the other one is this one here that I'm doing. And once you've removed those screws, you can open up the PCB towards you from this perspective I have right now. It hinges on the side with the transport buttons and the battery compartment. And the reason being that there's wires attaching the PCB to the battery compartment on the other side, so you want to hinge on that side. So it does take some finessing to kind of pull it up. You might want to put a finger on the DC jack, and kind of free that, because it tends to get really snug and stuck. And you want to kind of just work it up little by little, make sure you're not yanking on anything and breaking stuff. There's a little extra flex PCB near where my thumb is that also has to come up along with it, so that's why that side might be a little bit stiff for you when you try this yourself. You can see here I'm just trying to be extra careful. There I freed up the DC jack, and you can see that made a huge difference. And then the PCB is attached to the motor by some wires, so you can't completely open it up, but you can open it enough to do what we need to do. This thing's kind of a nightmare if you need to actually like do any circuit level repair work on it. It's very annoying to like have to deal with this sandwich of wires and boards. Anyway, the motor flywheel is concealed by this cover that we need to remove with 3 screws. The reason we need to remove this cover is because there's always belt goo underneath it that needs to be cleaned. So get that out of there. Keep track of all the screws. I use painter's tape, blue tape to keep track of screws. I fold up some tape and I write like a basic description of where the screws came from on the tape, and then I stick the little screws to that piece of tape, and then I start a new piece when I am starting a new section of screws. And that's how I keep track of screws. Very important to keep track of screws on these Walkmans because Sony sometimes liked to randomly switch screw types, and they can be deceptively similar looking and hard to keep track of. Anyway, I just took the cover off. Now we're looking at the flywheel on top of the copper brushes for the motor. That metal is a special, I think it's Mu metal, I don't know. It's like some kind of magnetized metal that reacts with those copper windings to spin it. It's very, very cool motor design. So that's just magnetically held in there. So I just pulled it out very delicately. And there is the center motor spindle that we need to clean. I'm just going to grab some of the goop with my tweezers, but you'll see it's not super effective to do that. You really need to just dig at it with something that's not going to damage it, which is why I use toothpicks. Sorry again about the camera angles. I'm 10x zooming on the camera and watching myself through the phone, trying to make sure that I'm in frame. It's kind of a weird thing. Anyways, here's the toothpick. Dig out all that gunk. And of course I am getting some of it on my fingers here, but you can't. You could wear latex gloves if you want, but I worked on 4 different Walkmans all on the same day today, so I kind of gave up on keeping clean fingers at that point. I just make sure that nothing on my fingers is transferring anywhere else. I wipe them off and keep going. And I'm using the wipe to clean the top of the spindle here as well. And then we're going to go back with a clean toothpick and continue working on it. You really want to focus on getting all this goop off because, like I said, it affects the new belt you put in. And also it directly, it more than anything else in the Walkman, this is going to be the deciding factor on how good your wow and flutter is. Basically the 3 main factors on this design of Walkman is getting all of the contact points for the belt need to be as clean as possible. The belt needs to be the right diameter. If you put a belt on that's too tight or too loose, it's going to affect wow and flutter, and it's also going to affect how well or how much wear is being put on the motor. You don't want to put on a belt that's too tight, or it's going to wear out the motor. So that's another factor. And then also using the right width of belts, like the thickness of the belt is also important on these. The belt can't be too thick or it will drag on certain parts of the mechanism, and it can't be too thin, otherwise it will kind of get eaten by the grooves of the copper wheels or the brass wheels. And if either of those 2 things are happening, it's going to dramatically increase wow and flutter. I don't personally know what wow and flutter numbers these Walkmans had when they were brand new and in like perfect service condition. I never owned a brand new one of this style back in the day. So I don't know, like, usually Sony doesn't mention wow and flutter in their schematics either, or their service manuals for Walkmans at least, because the numbers were never that impressive. Some of them they do, but you could correct me in the comments if it's known for this model, but I don't know that it is like officially from Sony. So I don't know again how well they are capable of performing, but typically when I'm done cleaning these and changing the belt and cleaning the roller and the capstan, I usually, like, the best I've seen out of one of these is like 0.17 WRMS. But like that's not really typical. That's the best I've seen. The average is usually more like 0.2 or like 1.9, somewhere in there, which is still perfectly listenable. I mean, that's par for the course for compact Walkmans. Like even the newer EX series, that's usually where they fall on the Wow and Flutter. And you're typically not going to hear that too much unless you're listening to like music with a lot of sustained notes, like classical instruments, or like artists that really hold a note for a long time. Like if you're listening to like I don't know, like Celine Dion or something along those lines, like you'll hear it, but typically you won't, like with other types of music. Anyway, I'm going in here with a Q-tip. I'm using clean room Q-tips here as well that don't they're not made from like cotton fibers or like strands that are gonna get left behind. These don't leave behind any fibers or residue. And I'm just kind of turning the wheel. You can see the finish of the wheel is ruined where the belt was, because the belt is literally corrosive. It eats the finish of the brass. And the longer it sits there as goop, the worse that corrosion is. And unfortunately, there's nothing, at least that I'm aware of, that you can do to kind of reverse that, short of just replacing the spindle. And there's not really like off-the-shelf replacements for that available. You could, of course, manufacture one if you know how to do that and have the money and the time, but there's like, you can't just go on eBay and buy another one. You'd have to salvage the motor from another similar Walkman that's in better condition. But we're not going to worry too much about that. It's not going to make that much of a difference in the final performance of the Walkman. It's not like the end of the world or anything. So now we're wiping off the inside surface of that motor cover with a isopropyl alcohol soaked wipe. And I'm being very delicate when I'm wiping it. I'm not like putting too much pressure on it because I don't want it to bend or anything. You might want to lay it on the table while you're cleaning it, but I've done this enough times that I know how to do it delicately. Just because if you bend this thing out of shape, it's going to start rubbing on the wheel that turns below it, and that'll create friction and drag, obviously. You don't want that. Once it's clean, we're going to put it right back in there. I find it's easier to use tweezers, but it's not really necessary. And line up the screw holes. There's 3 of them. And you do want to get these screws tight. You can see there's some green residue left behind because they had Loctite on them before, like thread securing glue, which means that they're supposed to be tight usually. And obviously the glue is to prevent vibrations from loosening the screws. I personally don't have this glue, so I don't put it back, but it wouldn't hurt to replace that glue for like added longevity of the repair. It's not like permanent thread locker. It's meant to be like a soft thread lock that can be easily broken by a screwdriver. So don't go overboard and like get permanent thread locker, or you'll never get the thing open again in your life. And again, I don't think it's really that necessary. I think you'll be fine without it. So now we're just going to go in and really thoroughly finish cleaning these other 2 wheels with Q-tips. And I basically am just pushing the edge of the Q-tip in where I can feel it going into the groove of the wheel, and then I'm turning the wheel slowly with my finger while I'm applying like counter-directional pressure with the Q-tip to kind of dig it in as far as possible. And I'm just going to keep rinsing and repeating with fresh isopropyl soaked Q-tips until I can run it all the way around without any residue coming up on the Q-tip, and that takes a while. It takes like probably 5 or 6 passes sometimes, depending on how dirty the wheel is. So here I'm zoomed in really close. Sorry about the poor angles. It's hard to manage a 10x zoom when the camera's hanging around your neck, but I'm just trying to demonstrate that even when you go around these capstans and pulleys with a wet Q-tip, it does not get all the stuff out. You can see there's still a thin line of corrosion and belt goop right there in the capstan, and there's also some still in this pulley. And the only way to get that out is by shoving something in the groove. And if you shove plastic in there, it's not soft enough to kind of mold into the brass, so it's not gonna get it all out. And if you shove metal in there like tweezers or something, you're ruining the surface of the brass, and you're doing more damage than if you were to just leave the goop in there, honestly. So toothpicks are perfect for this because the wood is soft and it will fold into that little crease in the groove and get all that stuff out. And that absolutely needs to come out. The corrosion needs to come out, otherwise it'll keep growing and eating at the brass, and the rubber needs to come out because otherwise it's gonna ruin your wound flutter, and it's gonna deposit oil and goop onto your brand new belt. So now that I've finished with the toothpicks, I'm going to go in and just try to check with a Q-tip one more time to see if anything comes off, clean the tops again, just to make sure that we're really done here. You can see I'm turning the wheel with my finger, and I'm applying counter pressure with my finger and with my Q-tip to really dig it in there as much as I can. And I'm cleaning the PCB above it and around it too, because sometimes the goopy belts will kind of drip and drop all over the surrounding areas and get goop there too. So you want to make sure the whole belt path needs to be clean. So I'm going to clean this all around this pulley, and then that spot where the two meet with the belt, and then all around the capstan. And you can see the Q-tip is clean, so I think we're done. Just gonna get the bottom of that flex cable too, just in case, but nothing came up. And the spot where the belt comes out from the motor pulley, again, it's clean, nothing's coming up. Just quadruple checking here. Yeah, we're done. So now we're getting ready to put that new belt on. The way you do it is you pinch it between your fingers to make a little loop. And I just realized I need to clean my fingers, so I'm going to wipe them with alcohol just to be sure that they're not oily and don't have any belt goo on them. At least none that's going to transfer. So we pinch the belt like this, make a little loop, and we stick the loop through the hole. And then I like to use a dental pick to kind of work it through the other side. I'm looking around for it right now, trying to find where I left it. It's right in front of me, but I have not found it yet in the video. There it is. Okay. So one side I've actually bent into a hook. That was actually like the toothpicking side. I bent it into a hook. And then the other side is like a softer edged open hook that's useful for pushing the belt around. See, I'm using it right there. So we're going to pull it through, and it's going to catch on everything along the way. So we want to kind of lift it over all that stuff in the corner that I'm just now noticing. And then we're going to let it hook onto the motor spindle. And then we're going to guide it around the capstan with our finger. And then it needs to be guided around the inner edge of that pulley, which it's easiest to do with your finger. And I continue trying to do it with the dental pick and finally got it, but just use your finger. Just push your finger up, like flat along, follow it along the edge of the pulley, and it will fall right into place. You want to make sure there's no twists or turns in your belt. I'm visually checking it right now, and it looks good. Any twists in the belt will result in wow and flutter, so you want to make sure you get rid of those. I think this belt is a little bit big because I see it getting slack when I did a quick direction change with my finger, but we'll leave it for now, and I'll find a tighter belt later. All right, well, now that the belt is in place, we need to kind of partially assemble this before we can test playback, because the motor is controlled by these two leaf switches or contact switches that are physically attached to this PCB, and they need to be lined up with part of the transport mechanism below it. And until you line them up properly, you will not have playback, and you will also not get sound. So you see I'm pointing to them right here. You need to be very careful with these. They're delicate. And when they get out of adjustment, it's kind of a process to fix them. So you want to make sure to avoid having to adjust them at all. You want to do all your movement by manipulating this piece that I'm moving right now. You don't want to move the leaf springs. You want to move this piece to line up with them. And there's a little black tooth on top of the white piece that I'm moving. The white piece is kind of a three-legged thing. It's like a little trident. And then that black piece is layered above it, and it lines up with the center point of that trident. So you want to line those up, line the center and the black piece up with, line them up between those two leaf spring sets, and then kind of wiggle the PCB up and down while you're lining that up to try to get it to like fall into place. And if you see the leaf springs folding or twisting while you're doing this, then you need to stop and try again, because you're doing it wrong. You don't want to fold them or bend them or twist them at all. They kind of just jostle into place. So just watch along with me here, and eventually I'll get it. The black piece is misaligned, so there we go. It just fell into place. You see that? The black piece and the middle of the trident are in the center there. The black piece moves up only. The trident moves up and down. So once those are in place, you want to lock it in with the screw. If later on when you're testing, if you don't have sound, it's probably because that leaf spring on the top there, the one that's labeled fast forward rewind, is probably touching in playback mode. It needs to not be touching while it's in playback mode. When those leaf springs are touching, it mutes the audio output. It's so that the cassette player can mute the head while it's fast forwarding and rewinding to save your eardrums. So if the leaf spring is misaligned, then it will be muting the output in playback. So you want to go back in, loosen that screw that I just put in, and try to realign the PCB again. It's easiest to actually do this while it's in playback mode, so you can hear when it's working and when it's not. If you can't get it in a position where it's not making contact, then you probably bent the leaf springs, and so you're going to need to go in and straighten them out and try again. So here I am trying to get that wire back underneath the PCB so that that little auxiliary board and capacitor can sit back where they need to sit. It's kind of a pain in the ass. I ended up having to undo my screw and lift the PCB up to tuck it in there. You'll see me doing it here. It's very delicate. I know it looks like I'm bending it a lot, but this is a very flexible PCB. It's not like a regular rigid PCB. It's a flexible PCB, so it's fine to bend it a little bit. Just don't go crazy. So now that is done, I'm going to put the screws in place for the PCB. It's just two of them, one on the flex cable and one that we already installed near the leaf springs. And now it is time to test the transport and make sure that our work is good. So we're going to put a battery in here, and you're going to watch me struggle to get it in correctly for some stupid reason, but eventually I'll get it in there. You shouldn't have to force it. If you're forcing it, that means that the negative side of the battery is not deep enough in the cavity. So just keep reseating it until it goes in nicely. Do not force it. This plastic is flexible and fragile. See there, it just dropped right in. And then the next thing you're going to need to do is plug some headphones into it, because this the WM-10 and F10 have a kill switch in the headphone jack. So if you don't have headphones plugged in, then it doesn't power itself on. It's a battery saving feature in case it accidentally gets engaged while it's in your pocket. So once you plug in headphones, the battery light should illuminate if the battery has good contact. If you do not get power, then check your battery placement. If your battery is installed properly, then you likely have corroded battery terminals, and you're going to need to clean those up. Hopefully alcohol will be enough to clean those up for you, but if it's really corroded, then you may have to clean up the surface of the metal with a jeweler's engraver pen or some very delicate sandpaper work. Anyways, now we can start putting this thing back together a little bit, but not too much, because I want to test the speed and the wow and flutter. So, and then I noticed right here, there's part of the belt is deposited on the bottom of the case here. That's a very common thing to have happen. So we're just gonna clean that mess up. You can see how absolutely vile and messy this shit is. Like the way that it just spreads around even with a clean cloth. I have to go in with a second cloth to get all the residue. So that's why you really want to be careful on how you initially clean up the belts, because if you'll end up making a bigger mess for yourself if you just start smearing it everywhere. You want to just pick it out surgically with a Q-tip, with a toothpick or a Q-tip, and then keep everything clean. So I don't unfortunately have a frequency counter. I just use my computer, which is good enough, but it's not the most accurate way to do this. And I use a wonderful program called NAC T100, which is a software emulator of a very expensive, well-known calibration device from Nakamichi. It's the T100. It measures speed and wow and flutter. This is just a software version of it. So right now I have a 3150 kilohertz tape, and I'm gonna dial in the speed right now. And you're just aiming to get it in the right ball. It was not that far off to begin with, to be honest. It was at 3156, so I'm gonna leave it at 3151-ish. That's good enough. And you can see the wow and flutter on this one is 0.22 right now. Cleaning the pinch roller and the capstan will probably lower that a little bit. There's the speed adjustment. And if you made it this far in your Walkman repair without wanting to throw everything out the window, this part will probably break you. This is the part where you put the bottom shell back on. It has these three button pieces that need to go back into the bottom shell. They have a groove cut in them so that they mate with the switch that's on the actual PCB that they touch. That slot needs to be facing upwards towards the PCB that's going to be in there. And you need to put them in advance so that they're already in the right spot for when the PCB gets placed in there, because there's not enough clearance to really add them after the fact. So I'm trying to line them all up here. You want to push them all in the same direction. So we're going to set that aside and make sure that the PCB switches line up with the direction we picked there. So I'm going to switch them all so they're towards the transport. And then we're going to start putting it into the shell. Now when you do this, you want to have the transport kind of at a 45-degree angle to the rear shell. And I've just noticed here I need to take the battery out. So take out the battery. Make sure that the felt puller, the cloth puller for the battery comes through so it doesn't get stuck underneath while you're putting it in. And then hold it to a 45-degree angle. And you want gravity to help you here, keeping these little button pieces in place. So I face them to the ground to keep them from falling. And then I put this in at a 45-degree angle. I line up the two edges first. The top and the bottom edge need to line up, so we're going to do that right now. I got the top lined up but not the bottom. They both need to go in. So we're going to keep doing it until we get it right. And then once you get those two lined up, then you can push the transport buttons through and start folding the PCB down so that it meets with those button pieces we put in. And you're going to notice while you're doing this that they move around a lot and they get jostled out of place, and you're going to want to throw the whole thing out the window. Just keep trying. And here I noticed that some wires were getting in my way, and actually on other Walkman W10s and F10s I've worked on, there's usually a piece of cloth tape holding these wires down, but this one doesn't have it for some reason, so I'm going to add it. This isn't like necessary, but it's helpful, so I'm going to add it in there. And then the spot that I put it, I decide it's actually too close to the volume knob, so I end up pulling it up and putting it down again. Once I'm happy, and then I get happy with the location and we can move on. Here's a close-up of where I'm putting that tape. You can see it's not passing that silk screen for the volume knob, but it's holding that pink and black wire down so that they don't get in my way. And after probably 30 minutes of doing this is the moment where I finally got it right. And it's, of course, out of frame. But it finally went in the way I wanted it to. And, looks like you can maybe see what I do here a little bit. I get those in there. And I close it without my thumb touching the stupid buttons. And yes. Got it to close down without the buttons coming up too much. I keep having to finesse them back in with the tweezers. There we go. There we go. And then I'm going to test the buttons here, and you'll see they all work. They should have a nice click, which means that they are touching the switch. Yes. Now we can start putting the screws in. And once you get those screws in, you're going to want to slide the door back on, and there is a right and wrong way to do this. If you feel metal scraping, then you're doing it wrong. There's those two long metal fingers that come off of the door. They need to slide into the groove between the metal shell and the plastic reel table on the top and the bottom relative to my video perspective. On the top side, you'll see there's actually a little metal loop that the finger needs to sleeve underneath, which I think I'll show here in a moment, hopefully. Will I? Can you open it back up? Yes. Come on. Okay, maybe I don't show it. I'm sorry. But yeah, you just want to make sure those fingers go in where they belong, and then you should get a nice smooth sliding action. If you feel resistance or scraping, you've misaligned those fingers, and you need to take it out and try again. So now we're going to put the door hinge screws back in. You want those to be nice and tight so that there's no wiggle in play when you slide the thing out. And I also like to check these door screws to make sure they're tight, or the hinge screws on the edge, because I've randomly seen those fall out sometimes while I'm working on the Walkman because they get loose over time, I guess. Again, those also have Loctite on the inside, but I think sometimes the Loctite gets broken somehow. I'm not really sure what happens, but I've seen it happen, so I'm warning you. Anyways, there we go. We're ready to put a tape in. And a battery. Oh wait, I almost forgot. We need to put the volume knob back on. So you need to put the clear washer back on there, line it up, and then you want to fit the volume knob on, and you can kind of just turn it until you feel it drop, because there's only one way it can fit on. It's an oval shaped fitment, and when you have it on correctly, it should be going up to 10 when you turn it clockwise, and down to 0 when you turn it counterclockwise. And then once you've verified that, you can put the screw in and get it finger tight, and then use tweezers to give it a final tighten. You don't need to like really torque it, just get it tight enough that it's not going to screw itself loose. Here I come with the tweezers. Make sure you don't scratch anything while you're doing this. And you also want to grab the base of your tweezers when you do this, or you'll end up torquing your tweezers and twisting them. I have a janky set of tweezers I use for this that's already ruined, so I don't care. Anyways, there we go. Checking fast forward and rewind. Playback. And I think I checked the radio here too at some point. Yep, there's the radio. There's the radio. It's working great. This one's good to go. Anyways, thanks for watching. Hopefully this video is not super long. My repair videos are never short. I'll try to speed this up as much as I can in post editing. Anyways, hopefully it won't be too long until the next repair video. I'm sorry for those of you that were hoping this would be about a CRT and not cassettes. I like to repair all kinds of stuff, not just old TVs. I'm really into vintage audio too, so I'll try to make the next video about a CRT, but no promises. Anyways, see you later.